Hey everyone. So yeah, this is meant to support some folks who need um, just a little bit more time going over area. Some folks are going to be comfortable with it, but they're pretty good examples. I didn't go over, I didn't create 10 of these problems to go over because again, I'm under that assumption that this is a somewhat comfortable topic for folks. Uh, but yeah, let's just kind of go in. So I have two questions in which I'm going to be just finding the missing area. So I can just straight up use my equations, plug in my known values, and go right to a calculator. And then I also have these cases where I'm actually given the area and I need to find one of the missing characteristics on the right hand side. But it should just be a matter of equation solving at that point. So looking at my two shapes, the first thing that I would want to be able to do is to identify those shapes. So this is going to be a trapezoid, okay? And this is our parallelogram. Parallelogram. So I know what equations that I want. And it's not uncommon for me to even write out the entire equation ahead of time. That way, um, I can see all the pieces and how they change basically as they go along. So this is going to be just base times height. All right, so let's see if I can finish up these problems. And I'm noticing on this problem that it's slightly more complex than even what I think is going to be on your worksheet, but that's okay. I'll do it as that question is intending us to. So let's look on the first trapezoid problem. Here I have 6 as being my top base, 8 as being this lower base, I believe. Um, let's see. It might actually want us to go and find this distance as well, which again, a little bit more complicated than kind of what I had intended, but that's going to be okay. We'll just go ahead and figure out that distance, which I need for basically base 2. And that is going to amount to doing some Pythagorean theorem. So that's 7 squared minus 4 squared equals x squared. 49 minus 16 equals x squared. So let's do that. So x squared equals 33. And I'm on my phone, so let's see. Square root. So I'm just going to treat this as 5.7 here. Okay. My entire base 2 at that point is going to be 13. So this entire distance is 13.7. And now I have all the information that I need in order to plug these in. So my half is going to stick around. Base 1 I'll call 6. Base 2, 13.7. And then my height is going to be 4. So notice this number never came into play here. This 7 only came into play in terms of finding my 5.7. Otherwise, it's kind of unnecessary. And then knowing the difference, like, oh, is this base 1 or is that base 2? You can use either. It's just addition between those two, so it doesn't matter which one's which. And then I'm going to basically calculate this out. So 13.7 plus 6 times a half times 4. I'm just plugging this into my calculator or into Desmos, and I get 39.4. I don't see any units of measure, so I don't need to really say anything. If I wanted to, you could say something like units squared, but really we don't have to put anything if we don't see anything. All right. Parallelogram is base times height. Right now I know that my base is 22. So basically I have 22 times my height, and the height is something that I currently do not know. So don't confuse your height with that 18. Again, that's kind of a somewhat, normally it's a miscellaneous piece of information if I'm given my height. In this case, I am going to use it to find my height. But in simpler problems, which I think are the ones that I've given you basically on your worksheets, you don't have to do this kind of Pythagorean theorem step. So here I'm just going to say 18 squared minus 12 squared equals x squared, very similar to what we did up top. So I'm going to get 324 minus 144. gives me 180, and then I'm going to square root that number. So I'm going to say, okay, that implies that x is 13.4. So that is going to be our height, which looks good if I just kind of check the reasonableness of it. If that's 12, that could be 13.4. So this now becomes area equals 22 times 13.4. And I'm going to get, 22 times 13.4. 294.8. Okay. Again, don't really need the units squared unless they give us that. So I'm just going to leave it as that. Here's a case in which I have the area. And this is another case where it's nice to start out with just your simple equation, because even if you don't know where to go, you can at least start saying, well, they told me the area, so now I've got 96. They told me one of the bases. I still don't know the other, so I can do this. This is just going to be times 8. So it at least gives you something to progress with. And now it's just a matter of solving this equation. So if I'm tasked with solving this equation, there are a number of different ways that I can do it. I might go with saying, okay, 96 equals, a half times 8. So a half times 8 is going to give me 4. So this is now 4 times 9 plus b2. And some folks might distribute that 4 at this point in time, which is totally fine to do. What I'm going to actually do is divide by 4 on both sides instead. So this is going to give me 24 equals 9 plus b2, and then subtracting 9 from both sides. So I get 15 equals base 2. So this is now 15. If I'm checking the reasonableness of it, I just want to make sure, definitely that it's over 9, but also proportionally in this particular diagram, it also looks good. So your worksheets are, basically a mix of the top and the bottom. You've got some questions in which you're just going to straight up find the area. And I actually think they're easier than these examples because you don't need Pythagorean theorem. And then you've got some cases where you're going to be given the area and you need to solve for the missing characteristics. So it's really just equation solving at that point. But if you have a question, maybe try to screenshot it, send it over in an email, and we'll take a look. All right. Thanks, everyone.